So to find the extrema points, remember the first thing is extrema is about the first derivative. So you're setting the first derivative equal to 0, and then you will draw a number line for the first derivative. So our first step, of course, is going to be to take the first derivative. So we get negative 3x squared plus 2x plus 8. And then because we're finding the extrema, we want to set the first derivative equal to 0. Now, when you look at this, you have a quadratic equation because the highest power is 2. So as a quadratic equation, you have several different methods. You can use your factoring method, and just keep in mind that if factoring does not work out for you, you can also go through the quadratic formula. And it's not like one method is better than the other. A lot of it is just what you feel most comfortable with. So in this case, we're going to model how we would go about factoring. Because we have 3 terms, we are going to do the whole first times the last that sums up to the middle. So we'll take negative 3 times our 8 to get negative 24. And we need 2 numbers that are going to multiply together to give us negative 24 and sum up to give us 2. So after working through this, we would get that those 2 numbers are 6 and negative 4. Because if we multiply 6 times negative 4, that gives us our negative 24. And if we add 6 minus 4, we get our positive 2. Now, with this combination, we then need to split up our middle term because we have this negative 3x squared. It's not just a 1. So what we do is we go back to the original polynomial, the negative 3x squared plus 2x plus 8 that we were trying to factor. And we split up the middle term of 2x into 6x minus 4x. So then we have our negative 3x squared plus 6x plus 8, setting that equal to 0. Now, with this particular factoring method, we're using the AC method. We factor by grouping. So we look at the first 2 terms and we say what is common to those 2 terms. And we see that it's a negative 3x. So we then divide this by negative 3x, and that gives us the leftover of just x. Divide this by negative 3x, and that gives us a leftover of minus 2. Going over to the second 2 terms, we then need to somehow get x minus 2. And in order to get the x minus 2, we look at what we have divided by what we want. So we have here a negative 4x, and we want to get an x. So if we simplify that, that tells us that we want to bring out a negative 4. And if we bring out that negative 4, you see you have negative 4 times x, that gives you the negative 4x. Negative 4 times negative 2 will give you the positive 8. So then the idea is for both of these groups, we have this x minus 2 factor. So that is a GCF for both groups. So our GCF now is x minus 2. And so we bring out 1 copy of that x minus 2. And then we have our leftovers, the negative 3x and the minus 4. Now, again, if you didn't want to go through that, you could also use the quadratic formula to get to the answer, but somehow you need to find the zeros of that polynomial. So once we factor it or do the quadratic formula, in this case, we would set each of these factors equal to 0, and that would give us the 2 answers of x is equal to 2. And then over here, when we add 4 to both sides, we would get negative 3x is equal to 4, divide by negative 3, and we get x is equal to negative 4/3. So those 2 numbers become our critical numbers. So with our critical numbers, we draw our number line. So we would take our 2 and negative 4/3 and draw a number line. Remember, negative 4/3 comes before 2. And we want to plug this into our derivative. Now, it's totally up to you. You can plug it into the derivative that is the negative 3x squared plus 2x plus 8, or you can decide to plug it into the factored form of the derivative, which we found is x minus 2, negative 3x minus 4. Remember, the whole goal here is just to find the sign that we have for the derivative at each of these intervals. So in this particular instance, for example, I might plug in, let's say, negative 100. And if I plug in negative 100, I'm going to get negative 300 here plus 200, negative 300 minus 200 plus 8. And so that's really going to give us a negative number. If I plug in 0, I'm going to have 0 plus 0 plus 8. So that gives us a positive. And if I plug in, let's say, positive 100, I am going to get a negative. All right, so what we have here is we have a negative that tells us that we are decreasing because we're talking about the first derivative. Then we have a positive, which tells us that we're increasing, and then a negative. So with that chart, we now have a relative minimum at x is equal to negative 4/3. And we have a max at x is equal to 2. Now, to find the y value, what we need to do is we need to plug it into the function, the original function. So this y value is going to come from plugging into the original function, and we get negative 230 over 27. And then here we will get 10.